Thank you. So in the last section, just I was briefing you about why data engineer, what is the role of Azure data engineer. And as compared to the previously, if you go back like 10 years, we won't see any kind of data engineer kind of concept, 10 to 15 years, right? So now we have got Azure data engineer as part of lot of responsibility where he has going to deal with different kinds of data. He need to play with different kinds of data, like the normal data, like structured data, unstructured data, semi-structured data. He want to work with the normal databases, SQL databases, NoSQL databases, streaming data, different kinds of things. But if we talk about, and even if you see, if you talk about previously, if we talk about ETL tools, we have got on-premises ETL tools like Informatica, if you see, handling only small amount of data. If we compare from 20 years ago and now, 1990s and 2000, data is very small. If you see, you should have got the storage systems that you used previously in 90s and 2000, early 2000s in MBs. You see that the data is very too small. Now, previously, if you talk, you have got floppy disks. You have got floppy disks to carry the data. Means just 1.44 MB was the size of it. Now, within this 1.44 MB of floppy disk, you cannot even store a smartphone image, right? A picture of the smartphone, right? But today, data is increasing enormously. Even the storage systems need to increase enormously. In the earlier stages of these mobile phones, should have seen the internal storage of the mobile phone just like 128 MB or 256 MB. Now 256 GB is also not sufficient, right? So data is increasing enormously for handling huge data, big data. You see lots of applications, not really like KBs of data, MBs of data, or GBs of data. Now data has reached petabytes. Previously, why is that the ETL tools were used to handle only small amount of data? Databases were there. This databases what we use like Oracle, MySQL, DB2. Like just I'll give a small example today as compared with Apache Spark, the Oracle or any other things, right? Yes. The speed as you compare with Apache Spark with any other technologies, right? Why you people generally choose for Spark, a very high speed processing, right? So databases, they can handle data up to some extent, but later we got some specialized databases, right? If you have heard about like Teradata, Netezza, Vertica, they are used for specialized databases used for data warehouse purposes. That too, they can handle data up to some extent. But for unlimited data storage, unlimited data processing, later you got technologies like big data, Hadoop, right? Later we are using now, currently we are using Apache Spark for huge data processing. So I'll come back to it. The advantages of Spark, you need to clearly understand why Spark. In Azure Data Engineering, the main execution weapon, Apache Spark. If you go to any data engineering course, Spark is compulsory today, where like 1 petabyte equal to 1024 TBs. Already 1 TB is the last storage unit. Today, data is generating in petabytes. If you take any applications, or if you take anything, like if you take Google, Twitter, Gmail, YouTube, Facebook, if you talk about e-commerce sites like Flipkart, Amazon, anything, any application generating petabytes of data. Previously, data was not in petabytes. This is 20 years ago. Just used to carry the data in CDs, compact disc in 700 MB. Later, you got DVDs. Later, USBs, right? So still data is increasing a lot. We need to have the storage systems and we need to have some processing systems accordingly. So for this huge data, right, we need to have some processing technologies with a very high rate of speed. Need to process that petabytes of data, or if you talk whatever data, right? Because whenever I'm talking here, like data engineer is going to pull the data from different sources. Data engineer is going to pull the data from different. So if you have got branches in 20 cities, from 20 cities, you are going to pull the data. You're bringing to one staging area, and where you want to apply some business logic and perform some kind of processing. Generally, from 20 branches, if you want to do some kind of business, okay, I want to just perform some business logic implementation on a particular product. A product of different branches. I need to bring it bring the data, filter the data of that particular product, and perform that business logic, and just try to analyze it. For that, you need to bring the data from different batches. Today, if you see, data is generating with a high rate of speed. See, the transactions are happening at a very high rate of speed. So in the same way, we need to have the same kind of processing. So today, as I said, I was discussing about the products previously. Today, I'll be discussing about the main important component like Azure Databricks and Spark. Just a second. Right. 1 second. Hmm. So cloud is majorly today, if you see cloud is majorly utilized. Say I was talking about in the previous sessions, I was talking what is the drawback previously, why you people are moving to the cloud, right? So if you talk, we need to set up your hardware infrastructure or on top of that OS installation, purchasing of data. See, if you see purchasing of database license, right? Uh, Whenever you are establishing any company, hardware, the cost of hardware it is 40%. It is the cost of the software will be around 60% of it. Okay, it's everything has to be licensed, right? Purchasing of database license, installation of database server, designing of database objects. To maintain all this, we require many teams are required. So here, hardware team, operating system team, networking team, security team, database administrators, right? All these things. But here, everything in the cloud, we don't need to maintain all these teams directly. How many systems required? Just you are just going to give that number of systems required, whatever you will be getting this, how, what is the RAM capacity, what is the processor, and what is the hardware configuration you want. Just you can choose it. No need to maintain all this. No need of OS installation. No need of all these things. That is what the importance of the cloud as compared with other things. On premises, right? We need to maintain all this. We talk about the Oracle database or any other databases or Informatica kind of ETL tools. All those are on premises. Now today we are expecting all on cloud based. We have got a lot of advantages on the clouds as compared with the on premises. Okay. So everything data engineer is responsible today. With the help of the cloud services, they work on data and make it structured and useful. So I was just talking about data engineer responsible for preparing, cleansing, transforming, processing, all this. You need to prepare the data, it's filter the data, cleansing the data, transforming it as per the required, and processing the data. After all these things, right, the data scientist is going to just perform some kind of recommendations on the processed data. Is going to strategize for the future, recommendations for the future. After this processed data on, so whatever it is, right, this data scientist or data analyst, they are going to visualize the data, and data scientist is going to recommend for the future. That's what I was saying. All the groundwork is done by the data engineer, the data scientist or analyst. And 70% of this analysis is done by data engineers. What are the sources from where I need to get the data from it? What are the sources of the data from where I need to get, whether it is from social media data, or it's a machine data, or it's a transactional data, what kind of data, what are the sources from where I need to bring, that is what the data engineering is involved. What is the format of the data, whether it is structured, unstructured, semi-structured, what kind of data it is, and how to transform it. And how means if it is like unstructured, how can I transform it in structured, and I need to perform some kind of, if it is into tables, I want like how to query it, what is the destination of the data, where I need to send the data. Okay. Yes. So major role of Azure data engineer, right? Entire from the source to the destination, from source to destination, from source to the target, how to move the data, right? And in between, we have to performing a series of transformations in between the source and the target. And finally, that processed data, you are just going to save it in the target. That is what entire data flow architecture and creating of data warehouse. Data warehouse where it is going to store that historical data, right, for storing of analytical data, right. ETL, the main task, extract data from different sources, transform that data and load the data. Data monitoring, data security, collaboration and communications with the data scientist and the business team, and analytics, some kind of analytics, right? It has some strong analytical skills to perform analysis. I was talking about Azure data engineering products or services. Azure SQL, Azure Data Lake, Azure Synapse Analytics, Azure Data Factory, Azure Databricks, Azure Cosmos DB, Azure Streaming, and Azure Key Vault. These are the mere Azure data engineering products or services, right? I was discussing about this in the last class in a simple way. Azure SQL, it is a cloud or DBMS, cloud or DBMS relational database system. Azure Data Lake, it is a kind of file system for storing the files that too with unlimited data storage in cloud that too. This is what Azure Data Lake, but what we are expecting further, I want a kind of database that too relational database, DBMS, that too for data warehouse purpose, for parallel processing, for batch applications, right? That is what Synapse Analytics. I'm expecting a cloud or DBMS, that too for data warehouse, that too I'm expecting batch and parallel processing. That is what Synapse for data warehouse operations, for big data operations, for batch applications, for parallel processing. See, one thing you need to see this data engineering here, it is we are not going to develop any kind of web applications. Understand clearly, we are not going to develop any kind of web applications here. We are not going to develop any kind of online applications here. It's not like the request response architecture we are not going to follow. The client server architecture we are not going to follow here. Means not online, there are two types of applications, online applications, batch applications. We are dealing with batch applications here. If you want to make a single, if you want to make an online transaction for a single record, two records, three records, okay. Here we are involving millions and trillions of records, millions and trillions of transactions. That to user non-interactive applications. User is nowhere required. Those kind of applications we will be giving here. But for the online application, user compulsory has to give the input. Here, no need of the user input, right? That's what we call batch applications. And big data operations, which involves like GBs or TBs of data. Previously, you used to have data in KBs or MBs, right? But the data is in like GBs or TBs of data, right? And that's why I want parallel processing. All right, that is what Azure Synapse Analytics. And if I talk Azure Data Factory, that's one of the important component in Azure Data Engineering. So here it's a cloud-based ETL. Simply I say cloud-based ETL. We talk OLTP systems, Oracle is there, SQL Server is there, MySQL, MongoDB. This for OLTP, online transactional processing for online applications. And for data warehouse, right, we have got Teradata, if you heard about it is also a specialized database used for data warehouse purpose. If you heard about this Teradata, Netija, Vertica, all these they are used for data warehouse. They are specialized databases used for data warehouse. Even Azure Synapse is there for data warehouse. In the case of OLTP to perform in Azure, we have got Azure SQL we got, but ADF, Azure Data Factory doesn't come in OLTP or data warehouse. It comes as an in the middle, right? It comes in, it doesn't come in OLTP, it doesn't come in data warehouse. It comes in between, right? It acts as an integration between this OLTP and data warehouse. It pulls the data from this databases to this data warehouse. ADF is going to extract the data. It's going to perform some kind of ETL, extract it, transform and loading, this kind of ETL. That's the cloud-based ETL. Yes, ADF is an integration service, transactions can separate OLTP systems. How to bring this means we have ETL. We have got many ETL tools like Informatica, Data Stage, and Talent. All these are on premises. Instead of on premises today, everyone we are going with cloud premises, right? But I need a ETL on cloud. That is what ADF. On premises means you have already got Informatica, Data Stage, Talent. Yes, but now we are going with this cloud-based things. Now using ADF, we can connect with the cloud databases, non-cloud databases, NoSQL databases. Using ADF, you can connect with any of these, cloud and non-cloud. and also like NoSQL, not only SQL.
Vijay, I have a question.
Yes, go ahead.
So by looking into this, like, data engineer roles, for example, some company has some requirement to establish some route for the data. So doesn't it look like a project based work when certain thing is done and then it's done? I mean, how it's like an ongoing job for as a database engineer? Does it make any sense?
No, no. Actually, once again, can you repeat it?
Yeah. So the kind of work, the job and responsibilities we are discussing about the data engineer role,
Mm,
to me it more look like a project based work where we establish certain routes and then we define these jobs will run and data will come here, and then once that is done, I mean the role of the data engineer is complete, right?
mm. Yes.
Then to me it looks like it's more like how it going to be like regular day-to-day work as a database engineer.
So okay, database engineering, like so it involves like you need to keep on pulling the data from different sources. Whatever source, right, is going to pull the data. So if you want any, see, data engineering means what is involved, different types of different sources of the data, like databases. It might be other cloud like AWS cloud, it can be, or Azure cloud, it can be, NoSQL database, it can be, right? Who is mainly
Mm-hmm.
responsible for all this? Data engineer is going to take care about all this. He's going to perform ETL. First thing is he's going to perform ETL. That too, today, like cloud-based ETL is important, because
Mm-hmm.
not only this, what I am talking about Azure Data Factory. First thing for any of these things to talk about, first thing is data is important. If you want to perform anything, any project, or if you want to do any task, first data is important. Who is going to
Yeah.
get the data for you?
Mm-hmm.
Data engineer. From where he is going to get, how to he is going to get, how is going to perform this kind of ETL is going to means, especially this Azure Data Factory, what I said is you can bring the data from anywhere. So in our real use cases also, in the today's use cases, I want to bring the data, I want to pull the data, I want to pull the data from Oracle, ADF can pull it. ADF wants to pull data from SQL server, it can pull it. ADF wants to pull the data from AWS, it can pull the data and can bring the data into our Azure storage from other clouds, from non-premises databases within the same cloud or other cloud or from other databases. It can pull the data, whatever data, right? First, data is important. After that, from that data, from that is what we call raw data. From that raw data, as per your task, what is required, that data only you are going to filter it.
Mm-hmm.
Want to analyze on particular year, or last 2 years, or last years, last 10 years, whatever it is, right? You are going to bring the first total data. From that, you are going to filter whatever data you want. That is what ETL, transform. Extract is the first one. Second is what? Transform. Transforming.
Mm-hmm.
Next, loading it. So for DSS, decision supporting systems, for all these things, for all this, we go for this. If you want to take a quick decision from this, data engineers are required.
Mm-hmm.
And here, some process, means scheduling we'll be doing here. You may say we'll be performing some kind of scheduling. Every day you
Mm-hmm.
want to run the task, every week you want to run the task, every month you want to run, or every hour you want to run. That what we the kind of scheduling we'll be performing. We'll schedule it as per, we have got different types of scheduling techniques available here. We'll be scheduling it. Yes. Not only that, right? So if you talk about now what I'm going to discuss, Azure Data Factory is one. But the total, what is the core part, what I'm going to discuss in Azure Data Engineering will be in Azure Databricks. Now what I'm going to discuss.
Mm-hmm.
You'll understand here as compared with other technologies. Why?
Yeah.
Other Databricks and Spark.
Just just wondering what would be the real life, example of where end-to-end solution is working. For example, I work in retail. Okay, my client is in retail, one of the biggest in Australia. So just wondering like Azure, how this data engineering or Azure data factory would help me in business.
Hmm. See, okay, for example, any kind of data. For example, today if data is coming in a JSON format, in XML format and JSON format most of the time. JSON
Yeah,
format, a key and a value format. Key
yeah.
and a value format. So I want to take the JSON data, and as a data engineer, I'll take the data. From the data, I'm going to create a tables, like
Mm-hmm.
SQL kind of tables. On that table, you can perform any kind of querying. Means one
Yeah,
thing
yeah,
is making the data structured and performing, make it structured and performing some kind of querying. And apart from that, right, for as per the business requirements, okay, uh, especially it deals with the huge data. If you talk about this Azure Databricks, where we'll be dealing with huge
mm-hmm.
data processing. If you got huge data is getting generated. See, for example, okay, I'm talking about Apache Spark here, the main execution engine here in this Azure Data Engineering. For example, at a rate of speed, the events are generated. At the same rate of speed, the events has to be processed.
Yeah,
At the rate of speed, the events are generating. At the same rate of speed, the events has to be processed. Means we need to have such a processing technology at very high rate of speed they are generating. In 1 second, for example, if you say in 1 second, lakhs of events are generated. Or if
yeah.
you say for in 1 minute, lakhs of events are generated. In the same 1 minute time only, the events has to be processed. But
Mm-hmm.
current technologies, what we talk, right? In 1 minute, 10 lakh events are generated, but to process that 10 lakh events, it is taking 1 hour time. Current
Mm-hmm.
processing technologies. That's why we have main processing execution engine here in Azure Data Engineering, that is Apache Spark, what we talk, very
Yeah.
high rate of speed. So it's same,
Mm-hmm.
for example, a labor example, if you take.
Mm-hmm.
So if you see, today, if you see a small labor example, if you take and traffic police, currently, if you got IoT devices, they are going to take pictures of this people who are going with the traffic violations or any other things that they're taking pics. Means in a minute, how many pics are taken? If overall
Yeah.
in, if you took entire state or entire country, if you take a lot in a minute, how many means events are generated? The rate of speed, in the same rate of speed, immediately they have to be processed. Immediately they have to be, means immediately you need to get the bill. That kind of
Yeah.
means IoT devices taking images and immediately forwarding it and storing it in that, and immediately all those events has to be processed. Everything in that way. That is one example. In the same way, if we talk about kind of streaming data is there today. Not only this streaming data. Streaming data means data which
Mm-hmm.
keeps on generating. Means, for example, if you take static data, if you take any movie data, if you're downloading any movie file, 2 GB, today morning it is 2 GB, afternoon it is 2 GB, after 10 days it will be 2 GB only. But not such kind of data, but we need to be handling, data engineer will be handling some data like, if you take any data like CCTV, a webcam. Today, like morning, it was 1 GB. Afternoon, it was 3 GB. Evening, it became 5 GB. After 10 days, it became 20 GB.
Yeah.
Keeps on generating such kind of streaming data, which keeps on incrementing. That kind of data you need to handle. And there
Mm-hmm.
are some kind of data, right? You will be getting NoSQL. Means in the case of SQL and NoSQL. SQL is there and NoSQL is there. NoSQL kind of data. SQL means from first record to the, see, if you see in like Oracle, you have got tables where you will be storing in the form of rows and columns. First record to the last record, same number of columns will be maintained here in SQL. Just before at the start of the session, even someone are asking what will be that Oracle. See, if you see the top 100 e-commerce websites, they're not using SQL. They are going with NoSQL today. Top 100 what was e-commerce websites, if you talk Flipkart, Amazon, all these things, right? They are going with NoSQL, right? The future, everything is NoSQL. Means in SQL, from first record to the last record, the same number of columns has to be maintained. In NoSQL means not only SQL, means a schemaless behavior. Record to record, different number of fields can be maintained. My first record with the 3 columns, second record with 5 fields, third record with the 10 fields, fourth record with 15 fields. Record to record, different number of fields can be maintained. That is what NoSQL. In the case of SQL, today if you have got some 10 columns, tomorrow if you want to add a new column, you need to alter the table schema. Alter, using alter. Again, tomorrow again, if I want to add a new column, every time I need to keep altering the table schema if I want to add a new column to the SQL. But in NoSQL, it's very simple. To a particular record, I want to add a column, you can add. If you talk about
Yeah,
example of social
yeah.
media only, like 1 second, Amazon, product, it's maintaining data. If you talk Amazon or Flipkart or anything, right? They are maintaining data. Means product 1, product 2, product 3, product 4. Product 1 doesn't mean that it should have 3 columns. Product 3 might be having 7 columns. Product 4 will have 10 columns. For example, Amazon books are there. 4 columns like name of the book, author of the book, price, and these things. To take the next product like electronics or home appliances, like in this way, different columns will be there for them. So in that kind, NoSQL is the better choice for them. We have got many NoSQL databases today, like NoSQL, like HBase, Cassandra, MongoDB, React, Peanut. Like in this way, many are there. In this way, even in the cloud, I was saying that there is a NoSQL database today, Cosmos DB, which is similar to MongoDB. We have got many NoSQL databases, graph-based, columnar store, graph store, key values, document store, right? In this way, many are there. So, like Cassandra, HBase, MongoDB, React, Peanut, Greenplum, many are there. So among all that, the famous NoSQL databases, Cassandra, MongoDB, HBase, these things. In cloud, we have got Cosmos DB. So that's what I was saying. Schema-less behavior, record to record, a different number of fields can be maintained, right? And random access we can perform. And now I was talking, can handle normal regular data, structured data, unstructured data, uh, these things. But if you talk about normal Oracle database, all this, many drawbacks are there. If you talk about Oracle databases itself, right? First thing is they can handle only limited data. Unlimited data is not possible for to store for databases. Secondly, most of the databases no parallel processing. And thirdly, if the volume of the data is increasing, the speed will decrease in most of the databases. And most major drawback with the databases, they can handle only structured data. They cannot handle unstructured or semi-structured data. Okay. So that's why here in this kind of technologies like Spark, where they can handle any varieties of data or huge volumes of data, different formats of data, handling any types of things. That's why we go with this. But here it is providing different tools in data engineering, like Azure Data Factory is one, Azure Databricks is one. In this way, Azure Synapse is one with different tools where we can handle this kind of data and process this kind of data. But for all these tools, right, the main thing, the main component we use is Spark. And if we talk the speed of Spark, Yahoo has conducted many tests to check the speed of different databases. Yahoo has taken a table. See the speed of this. Yahoo has taken a table of 100 TB, 100 TB, 100 TBs of data consisting of 1024 columns. And the task was sorting The task was sorting based on 16 columns, sorting based on 16 columns. What is the time taken? What is the time taken by? For example, just before you were talking like Oracle, if you talk, what is the time taken by Oracle? What is the time taken by database like Oracle? What is the time taken by MySQL? Oracle has taken nearly 3.5 days to process this. MySQL has taken around 6 days. And the popular the specialized database which is used for data warehouse purpose about Teradata, right? Teradata is a specialized database used for data warehouse where it can handle TBs of data, which has just taken 4.5 hours only. Another specialized database like Netija, which has just taken 3 hours of time. But if you heard, there is a big data tool, big data, which is used for both storage and processing. If you're aware about big data, Hadoop, you say, right? Big data Hadoop. It has just taken 3.4 minutes. It has just taken 3.4 minutes. These have taken days of time. These have taken hours of time, but Hadoop has taken minutes of time. Okay. Hadoop has taken 3.4. Spark, what we are going to deal in our course, Spark is 100 times faster. Hadoop. Now try to say the speed of Spark. It has taken 3.4 minutes. Then what is the speed of Spark? I'm saying Spark is 100 times faster than this Hadoop. Previously, Hadoop, there was a great demand for Hadoop previously. But when Spark came into the market, now everything, Apache Spark, very high speed processing, right? The processing, that too huge data. And these things, if you talk about this data engineering tools like Hadoop and Spark, they are bad for small data. They are good for huge data. Means for one record, two records, this Hadoop or Spark can't be used. It won't show you that much of performance. But for huge data in 8 GBs or TBs or PBs of data. So someone just now you asked, right? If you see that traditional databases or traditional ETL tools, huge data support is not present. Huge data means today minimum GBs or TBs or petabytes of data handling, right? So those handling those kind of data, but where it can handle unlimited data processing, that too with very quick rate of speed, 100 times faster, right? Yes. Yes, someone was asking a query, right? Yes.
Yeah. I had that question, but that was for different, different ground.
So here, what I mean, Apache Spark is the main execution engine what we'll be using in this Azure Databricks or Azure. In Azure Data Factory, we don't need to write any kind of Spark coding. I said everything is a drag and drop. In ADF, in Azure Data Factory, it's a total drag and drop only. It's a drag and drop. Means at least in we have got some kind of ETL tools like Informatica, where you used to do 80% drag and drop, 20% writing SQL scripts. But here, not even a single line of code you write in this Azure Data Factory. That is what Microsoft has introduced this tool where 0%, zero for code free. Mainly, I'm saying code free. Anyway, there is no prerequisites. Anybody can go with this. Just we are going to drag and drop. Even we are not going to write any kind of SQL kind of queries also in ADF. Very simple to deal with this kind of Azure Data Factory kind of tools. That is what a flexible tool that we can handle any data like on-premises data or cloud data or same cloud or other cloud, any kind of data you can just work with it. Means just what I'm saying is all transactions, see, just why I was talking about ADF, all transactions captured at OLTP. At OLTP systems like Azure SQL is there. How to bring these transactions into warehouse systems? We have got ETL. What kind of ETL? Already we have got this kind of ETL, but only for on-premise. But I'm expecting a cloud, that is ADF. Cloud databases for non-cloud and NoSQL databases. We can connect with any of this. and the ADF can be used. And later, if you want to write some customized, means if you want to deal with some complex kind of data, like graph data, for such kind of graph data or streaming data, or for complex data, right? We generally people we choose Databricks, where we can write customized code. We'll be writing our own code, and we'll maintain our own cluster here, and total execution is happening here. See here also in ADF at the back end, Spark is going to execute, but you don't need to write any kind of Spark coding. By default, it internally converts all this, whatever we are going to drag, right? That's what we call pipelines. That will be converted internally into this Spark code and executes and gives you the result here. But you don't need to write any kind of internally, it generates code and executes internally. We don't need to do anything there. But here we are going to write some kind of code in Azure Databricks, customized code. That's the reason this people, even if you go for Azure data engineering, right? You go for interviews, like they will say first you have got knowledge. So as a ADF developer, you can get job, you can step into the company, okay, with Azure Data Factory ADF developer. But as compared to that, people who has got knowledge with this Azure Databricks, still I didn't discuss about this Databricks. I'll be discussing more about this Databricks and other things in the tomorrow session. Here Databricks, what is Databricks means? Okay. In a simple word, what is Databricks? For example, very simple. I'm giving you a task. I'm giving you a task to do. Immediately what you ask? I want resource. I want a system with so and so configuration, everything. Provide me that resource, then only. In the same way, Spark is there, which is going to process it. It has to work on some cluster. So data, what is Databricks means? Provides a Spark cluster, provides a Spark cluster in cloud. So what is it? Databricks provides a Spark cluster. Spark cluster means, see, you've got some group of systems interconnected. They're interconnected. Okay. You may ask why this Spark has got this much very high rate of speed as compared with other things. Okay, even as compared with big data, Hadoop means today you no need to do anything. Everything taken by this Spark framework. Here, not client server architecture, master slave architecture. Master slave architecture. Single master, multiple slaves. See, for example, in this way, lot of systems are interconnected. S1, system 2, system 3, so on. Some 40 systems are there. In that, this is what group of systems connected in a network. So one will be the master in that. One remaining all will be the slaves. One will be the main driver. Remaining all will be the workers. Means whatever data, for example, you got one file f1.txt. This file of 2 peta or like 10 TB. 10 TB data, a file of 10 TB. Each system has got 1 TB storage, one assume 1 TB storage, 1 TB storage, one. Okay. 40 TB maximum it can store 40 systems means 40 TB. In this, for example, this 10 TB file cannot fit into any of this system. It will be split into smaller parts and is distributed across multiple systems and processed by multiple systems parallelly. So generally, work done by a single person, work done by 40%, see the speed. If a labor example, building construction, a work done by a single person, work done by 40%, see the speed, right? Here also, your data file is going to be distributed into 40 systems running parallelly, executing a single file object, giving the result. That is what very high speed you are going to see. This is in the case of Hadoop. The same thing, Hadoop, it is a kind of revolution. It brought a Hadoop has brought a revolution, right? Like the computation, right? Especially distributed computation, distributed computing. This has brought a revolution in this computation, that to distributed computing means data is distributed among multiple systems. 10 TB or 10 petabytes you take. Data is going to be distributed across that. You no need to distribute all these things. You no need to take care about all this. Everything taken by the framework itself. Your data is distributed across multiple systems, processed by multiple systems parallelly. That's why very high rate. That is, but in the case of Spark, whatever this 10 TB data is going to be stored not in the disk level, memory level, RAM level. Understand here, your data is going to be splitted and stored across multiple RAMs of multiple systems and processed. That's why very high rate of speed. When here, that's why here I've taken 3.4 minutes it has taken here, but Spark will be 100 times faster because of in Spark in-memory computation. In-memory computation. Memory level storage, memory level processing. Data is stored within the RAM level and processed within the memory level, right? That's why due to because of this in-memory computation, you see like very high speed in Spark. That's why today industry is expecting quick results. Industry is expecting fast processing. So that's why Spark is a very high speed processing technology. This much has got a great demand today. It has got many features are there. If you talk about the features, right? Spark features, MPP, massive parallel process, and second thing is in-memory computations. Generally, data will be stored in the disk and processed, but here, Spark data stored in the RAM level, memory level, and is processed. That's why very high speed. The RAM process, that is memory processing, that's RAM level and disk level processing. See the difference in that speed. If you take a disk level and if you compare this and this, if disk level means it is 10 times faster. If memory level, it is 100 times faster. Yes. So yes. So that's what the advantage of Spark today. So on the background, what all we are discussing the components, this Spark execution is going to happen. That's what I was saying, right? Spark can be implemented with multiple languages like Scala language, Python language, R language. So in our course, that language that we are going to use is Python. So this is what I will be discussing. Azure Data Factory, no coding, no language is required, nothing, no prerequisites for it. Everything will be very simple. We can step into the company. But if you want to have some bigger packages and if you want more calls, right, these two are important things, right? Azure Databricks and PySpark. PySpark is the execution engine. And for this, Azure Databricks is going to provide the things for execution for all. And that too, to be compatible with the Azure cloud means the data you need to take from this and you need to store the data into some Azure cloud. What kind of cloud? In Azure I'm using. The processed results if you want to store, if you want to take the input for all that, right? So Azure Databricks is to be compatible with this all kind of Azure storages. So yes, and Synapse Analytics also, it is one of the advanced level where it's a single stop solution for all your data related things, right? So yes, I just briefed you yesterday about this analytics for big data operations, for data warehouse operations, for batch applications, for online. Okay. So the people who are new to these things, right? I used some kind of technical words. If you should have seen yesterday and today, I'll be using some tech, not a worry. So during our course, everything I'll be briefing you about all these things, right? And this is what your storage is. Azure SQL for storing data in the form of tables. This is what storing the data in the form of files, any types of files, like normal text files, CSV files, JSON files, ORC files, Parquet files, right? And also we have got Azure Cosmos in the form of NoSQL. These are storages in the form of NoSQL. This is in SQL format. This is in files format. Storing files, storing in the form of tables. This is Cosmos DB for NoSQL, right? And this for streaming data. This is what the storages that we see here. So as a ADF developer, as a Databricks developer, as a PySpark developer, and as a data engineer, you will be interacting with this. You want a table, if your input is table, Azure SQL. If your input is a file, if input is a streaming kind of data, output is this table, output is a file. So you'll be interacting with these three things. As a ADF developer, Databricks developer, PySpark developer, you'll be interacting with all these things. Okay, can just check with the course content, right? In the chart, it is provided. The course content, and if you have missed anyone, if you have missed the previous session, you can just check with that link given there, right? Okay, you can just, okay, any other queries you got? I was briefing you about this Spark, right? But if you talk more on this Spark, they have got a lot of advantages. So it is lazy evaluated, I can say. Active evolution means immediately when defined executing. That is what active evolution. But a Spark is lazy evaluated. Lazy evaluated means when required, whenever required, when required, at that time, just you are going to execute. Just like in programming language, you have function. Until you make a call, it won't execute, right? To make a function call, then only it in the same way, your data flows will be there. The data flows will be executed when we perform some kind of X. Many things that I'll be discussing later about the Spark architecture, Spark processing, right? So yes. So I was talking about that today. If you see, lot of companies are using Azure and Azure storages, right? For kind of operations. So even lakhs of companies are getting registered and they're using Azure services. They in turn increasing, if you see the companies are in turn increasing the job opportunities for Azure data engineers. Means major companies, if you talk all the companies, they're adopting Azure and they require a lot of professionals who work on Azure and that too working with data, handling data, that too big data, huge data, right? Big data means data engineers who handles the data and who transform the data, process the data. Data engineer performs data management. Understand, data engineer is going to perform data management, data storage, data processing, transfer, all this. Data scientist mainly performs data analysis, predictions. Data analyst is just going to visualize the data and show it, right? So majorly the data engineer is going to maintain, manage the data, right? Yes. So that's why I was saying a lot of requirement for data engineers, like working with huge data. Even if you see data engineers, they have got the highest average salaries as closely as data scientists. The two highest, if you see why you need to choose this data engineering field means the two highest paying jobs today, if you see data science, data engineering, right? Data engineer and data scientist has got the two highest paying jobs. A typical data scientist even today is dependent on data engineer because it's pulling the data, transforming, processing, all is done by data engineer. Later, the data scientist is going to perform analysis on the process data of the data engineer. Yes. Even if you see a lot of companies, if you talk about Facebook, Intel, Microsoft, Amazon, all this, they're hiring data engineers with, if you see the salary packages, 1.5 times more than the other technologies. And even tech giants also, right? Like Apple, Cognizant, Walmart, this they're offering high paying jobs to data engineers. Only thing is you need to have great command on this entire thing. That's why we'll be spending some time. So it's not like you want to go as an experienced person, you need to have some full knowledge on this. We'll be discussing with many working examples. It's totally practical oriented, nothing theoretical. So I said you can do parallel along with me, whether what are the pipelines creations or notebooks creations, whatever we do, can do parallel along with me. So, it's all like this is I was talking most of the time, but it's a demo session. But normal sessions, you'll be interacting for each and every statement. What will be the next step? Next step means as a data engineer, what output you are going to get also you need to be knowing. You'll be knowing it. What output you are going to get if I perform, if I apply any functionality. That is what. So you can just check with the course content. We'll be discussing with this Azure Data Factory. Lot of you can see lot of course content. Azure Data Factory, what I'm going to discuss. Around 50 practical exercises I'll be discussing in this. Yes, and Azure Databricks. I'll give knowledge on this big data. What is big data? What is Hadoop? Before I go with introduction to Spark, before I go with Databricks computation, right? Where Databricks cluster management, displaying clusters, starting clusters. Don't think it will be like complex. It will look very simple and easier. If you're regular to the sessions, if you're doing that practicals regular, it looks very, very simple. Many inbuilt functionalities are there. You don't need to write huge codings, and that too, many built-in functionalities it is doing. Utilities, Databricks integrations, handling different file formats, Databricks batch processing, and streaming, and lakehouse, Delta Lake, and working workflows, scheduling, and Azure Synapse. These things you can check with the course content. So in depth, the time duration that for all these things to complete, like around 3 months. We're discussing all this, especially as compared with other training sites. Here I'll be discussing in brief about this PySpark, which is the main execution engine. But in the other training sites, they might be giving overview about this Spark, Databricks with Spark, but here we're briefing you about this because this is the main component. Even you can go as a PySpark developer, you can go as a Databricks developer, and as a data factory, as a data engineer, many roles as a Synapse developer, right? Yes. So if you got all this knowledge, it adds weightage to your resume, right? As a data engineer, total package, right? So it's a offer batch. It is given for an offer price. So generally, each one is a separate course. Each one is a separate course. Each one, but actually the course fee is 24,000, but 50% discount is applied. It's 12,000 where you will be getting all this. Also, data factory, database, PySpark, and Synapse Analytics. Fine. All this, the course fee is 12,000. Duration is 3 months. You'll be getting each and every session video, soft copy of this class notes, assignments and tasks, WhatsApp group, to live sessions, hands-on interview questions and results. For the first 1 week, it will be at 5 p.m. It will start later. It will be first 10 days, 1 week to 10 days. It will be at 5 p.m. Later, it will be at 6 p.m. Right? Yes. Yeah. Any other queries you got, anyone? Right? Is it difficult to someone comes from non-tech? The only thing, right? See, everything, all the prerequisites I'll be discussing. It's not like anyone means here I said, especially as kind of ADF, no kind of coding. If you see currently, if you go with software field, anywhere you see like coding, right? Especially this tool ADF is designed by Microsoft in such a way that zero coding is involved. Zero coding is involved for this. No coding at all, no prerequisites for this. But for this Databricks and this PySpark, you require some prerequisites like basic SQL, basic Python that I'll be discussing before I go with the practical part. Not the total things, basic knowledge is required. But only thing is regular to the sessions, interacting in the sessions, and doing the practicals, everything you can understand, right? It's one of the demanding tool in the market where you can even demand for the salaries. This is a kind of technology where you can demand for that. Even you have got a lot of calls as compared with other technologies, right? You got a lot of calls for Azure, this kind of data engineering course, right? Yes. Yes.
So, Vijay, do we have extension to this course? Like, if someone want to go into the data scientist field after this?
Yes, data scientist. I said the data engineering totally deals with data management. The data scientist totally deals with analysis and predictions.
Yeah,
Is
yeah,
the processed results right from this data engineering, right? A typical data scientist need to have the entire knowledge of data engineering and all these things actually. Today now is dependent on data engineer. After that, is going to perform these kind of things.
yeah, yeah. But my question was,
Data, yes, I
do
understood your query. Even if you want
yeah,
to have that knowledge on this data science, you can just go ahead forward. Means data engineering, data, see, wherever you deal with data engineering, data science, or data analyst, all
yeah,
dealing with data, but mainly the processing is done by data engineering, total data processing in that.
yeah,
And that is, if you want to go further and if you want to become like a data scientist, scientist level, right? That is what data science you need to have the knowledge for it.
Yeah.
Data engineer means this is what are the tools, what are the things we have discussed right today.
Yeah.
And if you want to go as a data scientist, you need to go for machine learning, deep learning, this AI things, right? For those things.
Mm-hmm.
There we have got many algorithms, models for that. You need to have some statistical knowledge for those things.
All right. Yeah. Okay.
Yeah.
So you guys only master in data engineering, right? Like
So this,
DurgaSoft.
no, data science courses also available, but this course, what we are discussing is data engineering.
Okay. So DurgaSoft also offer the other
Yeah,
courses.
data science, data analyst, data engineering, all courses are available. But this,
Okay.
whatever we are discussing, this course is data engineering, where
Mm-hmm.
we'll be discussing this.
Okay. 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 Thanks for the answer.
Any other queries? Like tomorrow also, everyone can attend the session, same timing at 5 o'clock using the same link. Tomorrow also,
Yeah.
we just to go with this. Everyone can attend the session, same link. But from day after tomorrow, we'll change the link, right? So,
Yeah.
so you can see tomorrow also. Just I'll be briefing you about this. Data engineering tools, right? And tomorrow, just I'll be dealing with what are the main things you see currently, right? Especially in data factory, as compared previously. Many versions were there. In the current latest version, how flexible it was made as compared to the previous versions, right? Okay. So thank you all for your time. If I'm done with the queries, if there are no other queries, I'll stop for now. Meet you tomorrow, same time, 5 o'clock, using the same link. More
Yeah.
discussion.
Yeah. Let's try to catch on the same time, exact time. Like, right. We are wasting 10-15 minutes every day now. Yeah.
No. Actually, for demo sessions, right? 10 minutes time will be given for all the students to bypass. Every day, some new students will be joining. So there'll be queries. So demo sessions, right? 10 minutes, there'll be some leverage given to the students to join. It's every demo session like 10 minutes, 5, 10 it talks. But
Yeah.
normal
But
regular
yeah.
sessions started in time. These are the demo session, but all these things again won't be repeated. But
Yes. So I think we completed demos now, right? So yeah.
no. Tomorrow also we go with this. From day after tomorrow, it will be that paid sessions.
Okay.
Okay.
Okay. Fine.
It's normal
Mhm.
for this kind of sessions, 10 minutes time will be given. But from day after tomorrow, we'll start at 10, 5 to 6.
Yeah.
But
Yeah. I think probably we can see who is new tomorrow, and then probably we can maybe start. If there is no one new person, then probably we can start, right?
yes, not a problem.
Yeah. Thank you. Thank you, Vijay. Thank you very much.
So I understood
Thank
it's
you.
then one more thing I understood it's a odd time to take this one, but it's not a online timing at all. Like somewhere like evening 8 o'clock, 9 o'clock, where all the job holders everybody can attend it. But still, there's I can understand most of the students they'll be following the videos, especially people from US, right? They'll be following the
Yes.
videos, daily videos will be forwarded to them. But okay,
Yeah, even hard for me. I'm from Sydney,
and
so
so like, there are many queries we got. It's a very odd timing. If I run the same session at 9 o'clock in the night or 8 o'clock, I can see 40, 30 students, right?
hmm.
Okay.
Yeah, but just keep it like this only because if it got extended, I cannot join. It would be midnight for me.
Clearly, I'm saying timing, right? First 10 days it will be at 5 to 6, later it will be to 6 to
Yeah,
7. Before you
yeah,
go,
yeah, yeah.
it is clearly said, right? Yes.
Yeah. Okay. Thank you.
Okay, meet you tomorrow with same link. Thank you all.